exploring Dockers and containers. So basically, let me tell you something about Prasham Sabadra first. Prasham has been one of the speakers at the earlier SURATi Tech Talk also, and this is the second time he has joined with us on this SURATi Tech Talks 2022. He is having 14 years of experience in the IT field, with 12 plus years of experience in SharePoint related platform. He's a SharePoint techie and Microsoft 365 consultant, as well as a Azure consultant. He's also a motivational and behavior speaker. He's author, blogger, and an avid reader. So he also runs his site called knowledge-junction.com. So everyone is requested to go and visit his site and see the content there. Today, in this particular session, he will be explaining us what Dockers are, what containers are, what is containerization platform, what are the softwares those are used, what is the difference between Docker and a virtual machine, and he will be also having few hands-on demos for that. So without wasting much of the time, I would hand over this session to Prasham Sabadra, the architect at APEXON, to continue with his presentation. Welcome, Prasham, and please take the baton.
Thank you, Tejas. Thank you so much for this warm welcome and the introduction. I'll share my screen. Okay, is it visible?
Yes, sir, it's visible.
Okay, thank you. Thanks a lot. So it's already introduction has done, and the topic is just simplifying Docker and container concepts. So yeah, I'm thankful to the sponsors, the SURATi Lab, Computer Society of India, and your user group. So I'm very much thankful for giving this opportunity to discuss here in this group. And I'm also thankful to my friend Hemant. Because of him, I'm introduced to this group last year as well, and this year as well. So it's the second time I'm presenting the session here. So it's who am I already. Tejas has given the detailed introduction, so I won't spend time here. I'll just move ahead for the next slide. So what is the agenda for today's discussion, for today's session? Recently, if I say the background, recently I started working on the Docker and Kubernetes. My organization has some native applications which we need to move to the containerization or Kubernetes platform. And so we started studying the Dockers and Kubernetes. So background is, when I started initially, it seems those concepts are like very complex, but as we move ahead, understood the technologies, understood these concepts, and it seems to be the good one, very easy. So here agenda is to discuss this, to clear the concepts, to understand the base concepts, and then move ahead for the advanced applications, to move to create the Docker images or containerize containers, or to move them on the Kubernetes. So we are going to discuss what was there before containerizations, what are actual means by the containers, what is virtual machines, the difference between containers and virtual, and then Docker. And then we will have some demo. I'm going to show you creating one .NET Core console application on Ubuntu box. Convert this .NET console application to the Docker image, and then execute it. So let's start. So I hope after this session, you guys will understand what is the container concept, what is the Docker concept, so what are the steps required to create the Docker images, few Docker commands, and basically you will get the starting pointers for Dockers and containers. Okay, so let's discuss what was the before containerization. If we go to around 2000 or something, for my business applications, there are the independent servers. So I need to have if I need to scale my application, either scale up or scale down. So I need to update those like the servers. I need to either add servers or remove servers. But then I didn't have an idea, even though my application is not required the specific size of hardware or something, I need to have those. So it requires like cost. Servers are used as low compared to their full capacity. Then we have maintenance, and so basically we are wasting up the organization resources, our computing power. So the servers are get IT team has to be focused on the servers each time. Whenever the application updates or changes, we need to check the servers and all those things, all those details. And then cost occurs if new application get added or application gets scaled up, then new server add. We don't know what the capacity will require, and that with the high capacity, even though those are not used as the full capacity, used as the capacity of the application. So those are the issues with the servers. Then the concept come of the virtualization. So virtualizations comes with concept on one server. We could have the multiple virtual machines, which will share, which will have their own operating systems. But then that can be saved. So then again they is because when we have so each virtual machine has their own operating system. So we still have the operating system maintenance, the patching of the operating systems, and the licensing part required for the operating system. Even the performance is slow since operating system boot up and these kind of things. So there are some virtualization concepts came in a good way to solve some problem of the independent servers, but then there are some downsides as well. And then we have the technology called containerization. So this containerization is nothing but the operating system level virtualization. But then what is meant by the operating system level virtualization? As we'll see the difference. What is the difference between virtual machines and the containers or the containerized platforms like Docker? But then these operating system, just for now to understand this operating system level virtualization means these containers is like the same like the machines, but those are sharing the operating system of the host server where those uh, containers are hosted. So this saves the cost. How it saves the cost? By the licensing of the operating systems, and so those problems of the virtual machines, those are get bit solved into this containerization. And it has a less maintenance since there is no operating systems, only the applications. So this was the how the evolution goes, how the evolution comes, and how we have now like the containerization platforms. So these, when we see now, you see, for example, when you see the market or when we started, these terms are like a like Dockers and the containers, containerization platforms, the Kubernetes, all these terms are like, but when but basically we need to understand what exactly this before we start. Whether our application, which we need to migrate from legacy applications or legacy code based to microservice based architecture, or to as other containers, whether those fits into it or not. What are those platforms? How to deployment happens, and how these applications get executed. So basically, starting point is what are the containers. In simple terms, what I understood, container is nothing but it's a software package, independent software package, we could say, isolated software package, we could say, which contains the code to perform the functionality or to give the features of that software, required libraries, when third-party libraries uh, or the libraries or the classes required for to execute those codes, and then other dependencies like JSON files or configuration files and all those files required. So it's a complete package of these related things. And those it's a separate because it is a complete package, so multiple packages that can be run executed at the same time without interfering in each other. So the standard definition, like a container is a standard unit of software that packages up code and all its dependencies, so the software can run quickly and reliably from one computing environment to another. There are the benefits of the containers as well. Like, so since there is no operating system shared to have to the execution to have this container, those are very lightweight. Those boots very fast. Those starters, so we could within the sub-seconds we could launch the container. So we could launch those software packages or these software units. And again, these are separated or isolated from all other processes of the host machine. So even though this one container goes down or something, it doesn't affect the other containers. It doesn't break the other containers or other software applications. So again, that was one point. The third point or important point is one of the developers has one of the challenges. We always says that everything works in the development environment, but when we move to the test environment or production environment, it goes down or something wrong happens or some bugs appears or some error appears. This is because the different environment on each environment, like on the development environment, test environment, production environment, there might be a different patches on each environment, different application softwares installed in these environments. But this doesn't happen with the containers because these are the self-contained systems, self-contained softwares. This carries them with the core required libraries and all dependencies with them. So we don't know, or developer no need to worry like this is working in my development environment or this is working in my demo and it's not working into the it's not working on the other environment, or it won't work in the test environment or the production environment. So this is one of the advantage of the containers. Let's move. These packages we also call it as a container image or a Docker image. We will see in detail what is what is a Docker image, what is a container image, and how to create those. But for now, to understand the concept of container, these are the software packages which contains to execute that software to run successfully software whatever it requires. So that was and as we discussed, we write code once, containerize it, and we could run it on any environment. I hope this will explain what are the containers basically. Now, as we discussing, as we see the evolving how those get evolved, like independent server, then the virtualization comes. So there we have the virtual machines, and then the containerizations platform. So we have there the containers. So what is exactly difference between the containers and virtual machines, or we could say the Docker images? So if you see this image on the screen, virtual machine, if you see, started with the physical server. So assuming that those virtual machines are hosted on physical server, we could host it into the cloud as well. Like we have virtual machine into the Azure as well. Same thing for the containers as well. We could host in physical server and in the cloud as well. Then the second layer comes the operating system. If you see the difference, virtual machine or under the Docker image, the operating system is a shared. Okay. And that was the technology, the virtualization technology, it comes with the hypervisor. And then we have on the virtual machine 1, virtual machine 2, 3, with their independent OS. We call it as a guest OS. The operating system is not shared. This is one of the major difference between the containers and the virtual machines. When we have a virtual machine have its independent operating system. If you go, for example, I'll give the example. If we create a virtual machine in our Azure environment, it will ask us for the respective operating system. This is not the case with the containers. We have there is a containerization platform. We call it as a Docker engine. We'll discuss what is the Docker engine, but then we have the container 1, container 2, container 3. And here the difference comes. The major difference or important point to understand the operating system. Okay, let's. So as we discussed the virtualization, operating system is shared across multiple containers, but for virtual machines, operating system is not shared. We call it as guest OS. Then if we have certain other criteria like performance, cost, maintenance, size, the containers are ahead with the virtual machines. Since if we discuss about the performance and speed, since containers does not require its operating system, those are lightweight. Virtual machine is relatively slow to boot since it required a long time to start up. Containers can be launched in the subsequent time as we discussed. Cost, here the bit cost is saved, operating system cost is not required. We require for virtual machines, we require the licenses for operating system. Same for the maintenance, OS maintenance, patches, the security, other stuff. In size, containers are more smaller in size than virtual machine, and the benefit of this smaller sizes, we could have the multiple container hosted on the host server or the host machine as compared to the virtual machines. So these are the few differences where we have the containers and virtual machines. Even though I would like to highlight the point here, even though we are discussing all the advantages of the containers and the virtual over the virtual machines, but there are the applications where we won't required every time to create the containers or to convert the application into the microservice based architecture or to use the Kubernetes. Sometimes we need to go for the virtual machines as well, but it varies depending on application basis, depending on application to application. So major step or first step to identify whether my application fits into which platform. Whether for me, physical server or the virtual machine is okay, or I need to migrate this application to the containerized or Dockerized images or something. So let's move. So this we discuss about the containers. What is the difference between containers and virtual machines? Let's move ahead and discuss what is a Docker. So Docker is nothing but this is a software. Again, this is developed by Docker Ions. It's a platform, or it gives us the environment where we could build our container applications. So to understand Docker, as we discussed, containers is nothing but one software unit or package which contains all its related dependencies and run independently. It's like isolated process in our host. So what is a Docker? Docker provides a platform to build a container applications, develop, build, run, and manage or distribute this application. This Docker is a Linux-based application. It's open source, and since it allows us to simplify the process, the develop, build in containers, it also we call it as a containerization plan. It is written in the Go programming language, which is very similar to if you know the C programming language. This Docker doesn't use hypervisor. We saw in the previous images. Docker supports all the versions of the operating systems like Linux, Windows, and Mac OS. There are the Docker desktops available as well for Windows, Linux, and Mac OS. And we will also install on our Ubuntu box the Docker. I will show you. So Docker is available in the many variants of the each operating system. It supports the Windows as well, and inbuilt as from onwards Microsoft Windows Server 2016. And you could have look once the docker.com site, which is a Docker official site. So if we discuss this about Docker, so it's our server might be in the cloud or in the on-premises environment where the operating system which is shared. Then it comes as a Docker engine. What is Docker engine? We will discuss in short, and then we could have our application. So this is like a layered architecture kind of thing. If we discuss about the Docker and where the Docker fits basically. Okay. Now, there are a few concepts to understand or before starting or before we go to the demo. Like for example, Docker image. So Docker image, this is nothing but a template or which contains the multiple file in the layered manner and which will require to have to create our container. Okay. Then this is a Docker engine which we saw into the previous figure. This Docker engine. This Docker engine is nothing but it's a technology, it's a platform for creating the containerized application. It is like a client server application. When we see a demo, we will discuss it. So when we install a Docker, it's become a Docker host. One daemon process executed all the time, we call it as a Docker. Then it provides some API, Docker engine. It compromises some REST API, which we'll discuss with our client with the daemon process. And then there are few commands like Docker images or Docker build, Docker run. Those are the command line interface for the Docker commands. We will see those. Where we are installing the Docker and we are executing that daemon process get executed, that server, that machine, we will call it as a Docker host. And then one more important concept like Docker registry. It's nothing but a list of Docker images. So those are it's nothing but the list of Docker images. So those are nothing but the templates to create the containers. So where we need to have those images, and we call it as a registry. So we could have either private registry or the public registry. When we install the Docker, we have one out-of-box registry there. We call it as a Docker hub. In that there are the sample of few images are there. Then we could have our own registry as well, either in the Azure or in the cloud somewhere. So these are nothing but the repositories to store the Docker images or the container images. Okay. Now say, so these are the still okay to concept to discuss what are the containers, what is the Docker. So again, repeating container is nothing but a isolated separate software unit. So which executed parallelly, independently, without affecting other processes. And there are some advantages, like those are lightweight and performance wise smaller in size. Then we have the Docker, which gives us the environment, which gives us the platform to create those container applications. Okay. Now so these are the concepts to understand. Okay, now let's have hands-on or demo. So there are few steps we'll just discuss, and then we'll see from that. So here, what we are trying to demonstrate, we are creating simple .NET Core application, a console application. That application we will create on our Ubuntu Linux box, and we will convert those. Once we'll run this application, it runs successfully, we will convert that application into the Dockerized image. How to do that? What are the requirements or prerequisites for that? For example, there is a concept called Docker file. So what is that Docker file? It requires and what it contains, several instructions. Then we'll also check how to make sure that on our Linux box that .NET Core is installed or not. Then how to check whether Docker is installed or not, and then convert this application to Dockerize, make it Dockerize, and then build and execute it. Okay. So before that, I'll go to my Azure environment. This is my Azure free trial environment. It's a tenant is like Knowledge Junction 1. On Microsoft.com. So this is my free trial Azure environment where I have created one virtual machine. So if I go to the home, you will see that there is a virtual machine called Knowledge Junction. So this is the virtual machines. So if I click or I'll view it, it started now. And these are the few details like it's a RAM 8 GB or CPUs and the size and all those things. Otherwise, all the default settings are getting selected here to create these virtual machines. And as we are discussing, this virtual machines requires the operating system. So it's a Linux Ubuntu 20 version this 0.04. Okay. So this is the virtual machine. These virtual machines I'm connecting to the RDP. So if I close this current instance of RDP, which I'm already connected, this creates, whenever we restart or start this virtual machine, it creates one dynamic public IP address. It changes its state. We could have the static as well, but I just for demo purposes kept it as a dynamic. I didn't made it the static one. Okay. And here you could we required when user is get created, you could change the password of the user as well. from reset password, you need to give the username ID and the password. So in my Azure environment, I have created this Ubuntu box, Linux box, virtual machine. Let's connect it. And we are going to connect it through the RDP. We could connect this with the SSH as well. If you go to here, the connect options, you will get here options like RDP, SSH, and STN as well. So, and we could test our connection here to these virtual machines, whether it's working out successfully or not. There are several SSH we could directly connect with the help of Putty. Putty is one, it's like a telnet kind of thing, one application where which allows us to connect to the to this virtual machine with the IP address. So then we'll get only the shell there. But since we are more like the Microsoft guys or something, we connect to like the all visually. So I use the RDP. There are several steps to connect this Azure Virtual Linux box with the RDP. Those I have added the blog into the reference section. What are the prerequisites required to connect the my Ubuntu box hosted in the Azure cloud through RDP. But I won't go into those detailed steps since we have our main focus is on the Docker and containers application. So I'll copy this IP address, mstsc, and let's have this. Putting my username and password. Okay. So before going to each details or each steps, I'll just want to show the applications. So this is I'm logged in with, this is the terminal on my Ubuntu box. This is I logged in with the user Prasham, and then this is the knowledge junction is the virtual machine name. Okay. So before going, I'll just show the output of the application first, and then we will go this step by step. So if I make it ls, here is my directories for this user, and there is one directory called hello world. So if I go to the hello world, so there you will see one CS post file, which is for the .NET console application hello world, and the program.cs file. If you see the content of program.cs file, let me show you the content of program.cs file. It just contains one line, console.writeLine hello world. So whenever we execute this application, we'll get the output in the terminal window or in the console like hello. Okay. Now, so for now, before going to the detail step, assume that this application is already developed here, and we need to execute the application. We need to see the output. So how to build? So there is .NET which is already installed in this my virtual machine. There is a command, it provides .NET, and then build. Since I'm already in this folder, I'm in the hello world folder, I no need to give the path of my project file or something, right? It pick up the project file from the current folder. So if I build it, see the output, 0 errors, 0 warnings, and see the path as well. So this is my user under the home directory. As we are in the hello world, it created the build.dll into this folder, and now run it. So we have like .NET. It prints the result hello. So far so we are good. We have like a .NET Core console applications which displays the hello world. Now how to convert this into the Docker? So for now, again, assume that Docker is installed on this virtual machines, and we could see that. Before that, I will show you the .NET info as well. With these commands, we will get the details that which version of .NET is there, like 6.0.101, and what is the base path where the SDK is installed, which runtime it is using, ASP.NET Core, like this. So it shows us that .NET is installed on this virtual machine. Okay. Now, see, assume that the Docker is also installed in this virtual machine. So we need to convert the application, the console applications which we created, into the Dockerized images. But then how to do that? Before that, we could see which are the images already there on this local system. So if you see this, we have the command called Docker images, which shows that which are the applications, which are the images created on this. So if you see this knowledge junction demo, these tag, all these image tag with the different tags. This is the latest tag. This is because we could have the multiple versions of the images as well. Okay, so this is the current local virtual machines repository. We could have our repository where we could upload these if we want to share these kind of images into the public repository where other team members or those could pull as well. So it's a pull and push kind of thing, these images into the repository. Okay, so this is the latest tag with, and this is one MCR, this estimate. So what is this image that we will discuss in short? Before that, I just want to show which are the images here. Now, how to convert basically that we will see. Okay, so let's start. The first step we have, if you go, I'm again going to the slideshow. If you see here, we need to make sure whether Docker is installed or not. So how to make sure if we could have the command like docker -version. So if you see here the details, this is the Docker, which version of the Docker is installed here, and which is the build. If in case Docker is not installed on this virtual machine, so if you see in the figure here, you will get command like you will get a message like command docker not found, but we could install it. How to install? There are the snaps available. So there is a command called, you see a detailed command called sudo snap install docker, so which will install the Docker on this virtual machine. This snap command and sudo command to execute this with the privileged access. Okay. Once it will, so this will download the Docker as well, and then install the Docker. We will get on the successful installation of the Docker, we'll get the message like, okay, from this installed. Okay, so in the interest of time, it's already installed on my virtual machines. Okay, and again we could make sure that by executing the same command whether Docker is installed or not. Once we have the install, the same step for the .NET. For the .NET, the snap is again like .NET-SDK. So how to check? We already see we could have the .NET version command, or we could have the info command, info parameter. So .NET-info it shows me like this .NET Core is installed on this virtual machine. Okay. If it is not again installed, we'll get like same message, command .NET not found, but can be installed with this. So we need to make sure whether .NET is installed or not. If not, we will install the .NET with sudo snap install .NET. These are the snaps when we started the installing this .NET and Docker. So just to have an idea. Okay. So the steps will require a Docker there. When we install the Docker, my virtual machine becomes the Docker host, the Docker daemon process which executes continuously in background. And then as we saw this, for example, Docker images. So this is my CLI, Docker images. So it's the command line interface, and this with the help of those REST API, it communicates with it gives the instructs to the Docker daemon or that daemon process. Okay. Next step is to create the .NET console applications. Here we saw that I already have created this hello world application. So let's move out of that directory. So I came again with the hello world. Now I'll create one new directory to have our new application, like say mcat demo SURATi demo. Okay, and here we will create our new console application. So how to create the .NET console application on this my OpenClass? It's very simple. We have step like we have a command, we have this .NET, and then we have a command like new console and the name of our application. Say for example, I go here .NET new console -n or -o. Okay, so see here, we'll get, if it is created successfully, we'll get the message like console app was created successfully. Okay, and this will be the path where the CS post file is there. Okay, let's go to, we already now in the that folder. Let's say ls. Okay, we have a folder. So we will see this program.cs and this is SURATi demo.cs. If we see the content of the program.cs file, that is, it contains out of box one console.writeline hello world application. Now this is, I'm doing all under the terminal basis. We could install the Visual Studio Code as well on this box, and I already had it installed. So if I open my Visual Studio Code just to demonstrate you guys, let's find it. Visual Studio Code, let's launch it. So this is the Visual Studio. How to install? The same way, snap install code. That was the same command. Okay, we could directly start rather than finding this and closing it again. We could directly start from here as well by the help of code command. Okay, it will launch the Visual Studio Code. With this Visual Studio Code, I have extension as well for C# language, since we are like a .NET Core console application in C#. And here we could open our folder. So which folder we have created? This is the folder. Okay, so if we created a folder, here we have the program.cs file. Here we have the CS post file, which version of the framework and the output time and all those things. Okay, that is okay. It prompts us for extensions and all those things. So we could run from here as well. We could start the new terminal, and we could run this application from here as well. Okay, from the Visual Studio Code itself. Because for console applications, terminal is okay, but my applications has the multiple file or big application, I need a Visual Studio Code on this my own. Okay, and this is if you run the .NET document, hello world. From this terminal only, we could also run the Docker commands, like for example here as it goes. Okay, let's move again. I'll move to the slides here. So we have created a console applications, we have executed it. Now let's move to step 4. Now this important point, how I convert my application or this container, this .NET Core application to a Docker image or the container image. So basically we need to publish this as a release because we are creating container images. So there is a command called publish. Here is the command given, and it will create one into the release folder. So if I publish this, yeah, so it created the release folder .NET 6.0, and here it copied the DLL and exe. We could go and check this one. Let's see once. If I go to the folder structure, sorry, this is our folder bin. There is a now folder release, and these are the files. This is our executable file, JSON file required, DLL file, and it contains those references too as well. Okay. So basically, that was the concept. It contains all the its required references to execute this. Okay. Now we have the publish as well. Now build this image. To build the image, we required a Docker file. Now, what is a Docker file? We didn't discuss this thing about Docker file. So let's discuss before building the Docker image. For that, our console applications which we created now. Let's have discuss what is the Docker file. This Docker file is nothing but one simple text file. It's a text file without extension. So it doesn't have that .txt extension or something. It contains some instructions. So these are the predefined instructions. I will show you which are predefined instructions. And this file is used by Docker build command to create the Docker image, to create the container images. Okay. So what is the syntax? There is some predefined syntax for this Docker file. For example, if you see on this slide, point number 6, Docker file always start with the from command. First thing. Second thing, whenever we create a Docker image or container image, we will need some base image from which we created. Here we have created the .NET Core console application, so required base image like from the ASP runtime image or something. If we create the Hello World application with the help of Node.js or something, then we require the base images for to have the to have that Node.js or something. Okay, so there are a couple of things. This is a simple text file without extension. This file is required by Docker commands, say Docker build command to create the images. What this file contains? This file contains few instructions to have those Docker images in place. This file always start with the from instructions. So it's a standard syntax, from and base image name, from which the image which we are creating will be derived from, inherited from. Okay, so let's see the example of here. We have a Docker build to create the image name, and the Docker file is the input. Okay, now the example of Docker file, let's create one in OS. We'll create in Visual Studio Code. So here I am creating a new file. One more important file is this Docker file naming convention is a case sensitive, so it requires in this format of D capital, F capital, Docker file without any extension. As we are mentioning, this is always start with this from instructions. Okay, now from instruction, then let me go back. Yeah, from here we will require, I'll just copy it from our previous example. I'll go there and copy it from there, because this is very like case sensitive, and it fails if it is not in proper syntax. So I'm opening this, open Visual Studio Code. Yeah, it open here. Here, this is the from instruction. Let's copy it. Okay. And here you notice this is the base image which is already available publicly, which will require. So our image which will require to execute our .NET Core console applications. This runtime will require, and that's why we are deriving from these base images. Okay. Now we won't go much in other instructions. We will go into the details. Before that, we will just build the Docker image. So there is a command Docker build. We have to give the image name and give the input of the Docker file. Okay, so Docker, sorry, build. What is the image name? Let's have this -f with the Docker file and dot. This dot indicates the current folder. Docker file is available in the current folder. Let's have it. Yeah, this repository name must be into the lowercase. So I need to convert this into the lowercase. The Docker file cannot be empty, it's not saved. So save it. I saved it. Let's execute the command again. Yeah, so if you notice here on the screen, step 1 from this successfully built, successfully tagged, latest one. Now how I'll check whether this image is getting created or not? With the help of command docker images. So if you see here, this is our one. Okay, so we have now with us the docker images with the tag latest one. Okay, as previously we were saying, what is this one? This is our previously created knowledge junction demo. Recently we created this SURATi demo for our console applications which we created. As this is the image as well, which is getting downloaded, from which we are deriving. So it shows here as well. Okay, so in this way now we are ready with our docker image. Now how to see the output, like our application.NET console, core console application shows the output hello. How to show? So there are few other instructions. Which are those instructions? Let's see. I'll again copy it from another docker file which is already there, and then we'll discuss more about it. So I'm copying it. Okay. So these are the predefined instructions contains the contain in a Docker file. So what we are doing here, we are copying these whatever publish that our application is published, whatever in that folder to the app folder. Okay, and we are changing the directory to the working directory to the app folder. Okay, here, and we are, since this is a console applications, we have the DLL. Here we need to change the DLL of name of our DLL, which we will get from here. If we do the ALS, so our DLL, let's go to the bin folder, this folder, it's the runtime version folder, and you will see that our demo, our DLL name is, our assembly name is SURATi demo, so that we need to change demo.dll. Okay, what is this .NET? If we see the syntax here, this is like the applications which we need to execute, like for example the .NET, as we are doing separately there in the .NET commands, and then this is the input as a like application, or this is the input of our application, the file which we need to execute. So let's build it. Whenever we change this, make sure whenever we change this Docker file, we'll need to make sure it is saved, first thing, and second thing, we build it again. If we directly run the docker run command, it won't show anything because it's not not get built at first. Okay, so let's build it again. We'll overwrite. Right. Okay, see that we this file location is in our folder, so we need to come outside. Yeah, and run the command again. See, we are running these commands into the Visual Studio Code terminal. We could run this directly separately over Ubuntu terminal as well. Okay, and if you see here, these are the steps now: copied, working directory, app. If I now show you the app directory, there we will see these files. So I'm into the home Prasham, into the app. Let me check whether those came there or not. Let me check. Okay. Okay, let's execute this this one, and then we will check it again. So these are the copies. Working directory is changed to the app directory, and then this is the entry point. Now let's run the application. So we have the Docker images which are ready to execute, which are ready to have the content. When we run this, it is it's like a container image. Okay, and there is a command called .net. Docker run. Let me check the exact syntax one. From the slides. Okay, so how this is the we change Docker run and the image name. Okay, let's go back into the Visual Studio Code. I'm not sure whether it's closed. Let's open it again. Launch it again. In our folder, this one, and there we go. Run Docker run and our image name. And you see the output. Hello. Okay. So in this way, we have created one Docker. We have created one application. So for demo purpose, we have created our one console application. We make it executed successfully on our Ubuntu box. Then we make it Dockerize with the help of those Docker instructions or Docker commands, and then we executed it. Okay, so that was like a demo how it works, and how we could make or how we could migrate our applications to the Dockerized version. Okay, let's go back to the slideshow. I still need to check one thing. Let's go back to the slideshow. Okay, so in this way, in the slides, I try to explain all those instructions and the steps in detail with the commands and the output. Okay. In the references sections, there are the articles which we have written on knowledge-junction site, starting with the Docker, the concepts and the container concepts. If you go to this link, index containerization, where you will find the multiple articles related to those details for instructions as well. What is that entry point and copy and other instructions as well. So those. Any questions or feedback or suggestion? Any point which is not get clarified?
Yeah, Prasham, we don't see any questions right now in the chat window, and no one has even raised their hand as of now. So I think your presentation was really good, and you have covered all the bases very well, so that there are no questions to ask, right? So if you have any closing comments, you have a couple of minutes more so that you can make closing comments, and after that I will sum up the meeting.
Okay, sure, Tejas, thank you. Yeah, so you have any questions or any doubts or related to these Docker containers? Next step is to this is the we're working on the Kubernetes. How to now this Docker image is ready, container image is ready. How to have this is on the Kubernetes platform. So you need to more details related to this. Feel free to contact me anytime directly or with the help of this group. And you could have the articles on knowledge-junction there, where we shared the detailed articles. You could touch base with me with the Twitter, LinkedIn, or you could directly mail me as well. Okay, then.
Sure, Prasham. Thanks for your time, and thanks all the attendees for attending this particular session. Prasham, you are like a veteran over here. You were earlier also at the SURATi TechTalks, and currently you have delivered this talk. So I'm sure we would be liking to you to come again and again on our SURATi TechTalks series in the future too. So once again, thanks for coming to this session, and thanks for all the efforts you have put in the presentation, and thanks for the wonderful presentations. Bye bye and have a nice time.
Thank you so much, and you too have a great time. Thank you. Bye bye.